Hi there, my name is Mitch Haralabidis, and in this video we will work together 4 exercises in which we will use our calculator, and more specifically the calculator we use in my school, which is the CASIO FX CG50. So we will use this calculator to firstly create any required regression model based on the needs of each exercise, and then using this model to predict a specific value for a given input value. To begin with, let's see exercise 1. In a certain experiment, the growth of a virus colony can be modeled by a geometric sequence starting at day 1. On day 5, the population was 5,000 viruses. So the given info we have already, let me highlight it, is that on day 5, we have 5,000 viruses. So when D is 5, virus is 5,000. On day 9, a second info, we have 62,500 viruses. So once again, when D is 9, the level of virus is at 62,500. What was the population on day 7 based on the simulation? So first of all, we will create a model. We know that it can be modeled by a geometric sequence. A geometric sequence is an exponential model of the form a times b to the power of x. We should not be disheartened. We have the calculator on our side. So with the calculator, remember that this is the main menu of it. We go to statistics. On list 1 and list 2, we need to plug in the given pair of data. We know that when D is 5, that is the independent variable, then the virus, which stands for the dependent variable, is at 5,000. So 5,000. And when D is 9, then the virus is at 62,500. Once we plug in our data, we then click graph F1, graph 1 again, F1 again, and we can see these two data being plotted. Then F1, calc, and at this point, we should state the needed regression model. We need an exponential one. Here, at first, we can see a linear at x, a quadratic at x squared, a third degree, f6 for more options, quartic, x to the power of 4, logarithmic, exponential. So f3, which type? A times b to the power of x, f of 2, and there it is. So far, we know that this model should be y equals 212.732 times 1.88 to the power of x. But we will not need that. We will click on the draw. And the GTC just drew it for us. What do we need? We need the specific value when day is 7. So shift gsolve ycal x7. And we have that the value is 17,677, which is none of these for some reason. I must have done a small mistake. Let's change this to 17,677, and that would be D. Let's move on exercise 2. The table shows the number of electric cars in thousands registered in a city starting from 2015, which stands for T equals 0, modeled with a quartic regression. That's what we needed. Once again, we will go to the menu, statistics. Let me go exit, exit, exit. Let's clear out everything. And I will need to plug in these in list 1 and these numbers in list 2. So 0, 3, sorry, 0, 3, 6, 9, and 12. And then 2, 10, 22, 40, and 65. Once we have them, graph F1, graph 1, F1 again, calc, we need the quartic regression. So we need the x to the power of 4. X to the power of 4, draw, and there it is. What do we need? We need a specific value when t is 16. Okay, shift G-solve ycal at 16. Exe, it's 109.078, so it is obviously A. Third example. The following table gives the volume V in cubic centimeters of a crystal for selected growing times T in weeks. We have time T in weeks getting the values of 2, 3, 4, 5, and 7. This will stand for the independent variable, and then the corresponding dependent variables values will be 150, 215, 270, and so on. So, like before, we will begin by plugging in these values in my GDC. 2, 3, 4, 5, and 7, 150, 215, 270, 320, and 420. And then again, graph, which is F1, again F1, and calc. Now we will select the needed model. The model this time is the logarithmic one. We have x squared, x cubed. We need F6 for more options. Logarithmic f of 2. These are the given, everything that we need to do to determine the actual equation of that, but we don't need this. We will just draw it. There it is. And since we need a specific value, we will click on the Shift, G-solve, ycal, and then that specific value, x equals 6. The answer is 369.55. 369, that would be A. And the fourth one, let's clear out everything. By now, you should all understand that the process is always the same. The only differentiation is when we actually select the needed model. So again, I will need to plug in the values 1, 4, 7, 8, 10, and 12. And then the corresponding y values, 15.5, 25.8, 26, 17.2, and 7. Again, F1 graph 1, and then calc. We need here a sinusoidal model. So F6 for more options, it's this, the sign. F5, draw, and there it is. We need a specific value when t equals 5. So shift, G-solve, ycal 5, exe, and there it is, 20.6. The right answer is B. So finally, remember that all it takes from you is plug in the proper lists, list 1 and list 2, your given data, then graph 1, calc, then the GDC will ask from you to state the needed model. You search through the tabs the required model, draw, it draws that model, and then shift, G-solve, and the value you need. That is all. You need practice. You can practice with these exercises again and again. In case you don't understand something, in case you still have questions, please don't be shy. Leave them below the comment section. As always, thank you for watching and thank you for your time.